This is the second of a five-part series on functions. Part 1 defines functions and provides some needed vocabulary. Part 2 considers notations used for functions and how to find function values for given inputs. Part 3 looks at algebraic operations of functions, adding, subtracting, multiplying, and dividing. It also suggests instances when the domains of functions need to be adjusted based on those algebraic operations. Part 4 looks at function composition, defining it and looking at composition both for values and for the general case. Part 5 formally defines a function inverse and provides a method for finding the inverse for a function. Examples of all material are worked through in each resource. When we discussed functions in the previous resource, we always simply listed the coordinates of all the points. The official math name for this format is roster notation. However, there is another notation used to define functions called, oddly enough, function notation. This notation provides a rule for calculating a function value based on our choice of input. The notation looks like f parentheses x close parentheses equals whatever the rule is. We read this as f of x equals whatever. Be careful with function notation. The x inside the parentheses does not mean to multiply. The x is a general case that represents what we will do to whatever is our choice of input. How do we actually find these function values? Think of the x as a holding space to fill with some input. I sometimes actually rewrite the function rule with an empty box wherever the x appears, so that I realize my input has to fill in each appearance of x. Next, we actually plug the appropriate input in for all the x's. Then the problem becomes a straightforward math problem that we will complete using the correct order of operations. For example, suppose f of x equals 2x plus 1. We want to find f of 4 and f of negative 7. To find f of 4, we take the 4 and plug it in every place we had an x. So f of 4 equals 2 multiplied by 4 plus 1, which equals 9. F of negative 7 becomes 2 multiplied by negative 7 plus 1, which is negative 13. What if f of x equals x squared minus 5x plus 11? What would f of 4 and f of negative 7 equal in this case? F of 4 would equal 4 squared minus 5 multiplied by 4 plus 11. Completing the multiplications and exponents, this equals 16 minus 20 plus 11. F of 4 equals 7. F of negative 7 equals negative 7 squared minus 5 multiplied by negative 7 plus 11. This results in 49 plus 35 plus 11. F of negative 7 equals 95.